For decades, astronomers have studied a young star system located only 63 light-years away. They photographed its planets, examined its enormous disk of dust, and believed they understood its basic structure. But hidden inside that bright cosmic dust was something they had completely missed. A giant planet, more than twice the mass of Jupiter, was quietly orbiting the star. It was not discovered because scientists saw the planet clearly. Instead, the James Webb Space Telescope detected something far more subtle, a chemical fingerprint hidden inside the light. And this unexpected discovery may completely change how astronomers search for planets that ordinary telescopes cannot see. This is Beta Pictoris d, the hidden planet discovered inside one of the most studied planetary systems in our galaxy. Beta Pictoris is a young, bright star located approximately 63 light-years from Earth in the constellation Pictor. In astronomical terms, that makes it one of our relatively close stellar neighbors. But what makes Beta Pictoris especially important is its age. The system is estimated to be only around 23 million years old. Our own solar system, by comparison, is approximately 4.6 billion years old. Beta Pictoris is therefore like a young version of a planetary system still going through its early stages of development. Around the star is a massive disk containing dust, rocks, and debris left over from the formation of planets. Astronomers have studied this disk for decades because it provides a rare opportunity to observe how young planets interact with the material surrounding them. Before the latest discovery, scientists already knew about two giant planets in the system. They were called Beta Pictoris b and Beta Pictoris c. Beta Pictoris b became famous because it was among the first planets outside our solar system to be directly photographed. But the system was hiding another world. The strange part of this discovery is that astronomers were not originally searching for a new planet. They were using the James Webb Space Telescope to study the atmosphere of Beta Pictoris b, a planet scientists already knew existed. For this observation, researchers used an instrument called NIRSpec, the near-infrared spectrograph. Unlike an ordinary camera, a spectrograph does not simply produce a photograph. It separates light into different wavelengths. Different gases absorb light at specific wavelengths, leaving patterns that work almost like chemical barcodes. By examining these patterns, scientists can identify gases inside the atmospheres of distant planets. While analyzing the Webb data, researchers noticed an unexpected signal coming from another location in the system. The signal contained a series of peaks and dips that did not match the smooth light expected from ordinary dust. Instead, the pattern resembled the chemical signature of carbon monoxide, a gas commonly expected inside the atmospheres of giant planets. Something was hiding behind the dust. Beta Pictoris contains one of the brightest known debris disks. The dust surrounding the star reflects and scatters starlight, creating something similar to a thick layer of cosmic fog. Imagine trying to see a small light through dense mist while an extremely bright spotlight is shining directly toward you. That is similar to the challenge astronomers face when attempting to photograph a planet close to its star. Stars can be millions or even billions of times brighter than the planets orbiting them. The debris around Beta Pictoris made this problem even more difficult. Conventional images could not easily separate the hidden planet from the surrounding structures. But Webb's spectrograph approached the problem differently. Instead of searching only for the planet's visible shape, researchers searched for molecules. Dust and planetary atmospheres produced different spectral patterns. The carbon monoxide signature allowed the team to isolate light coming from a planetary atmosphere while largely ignoring the scattered light from the surrounding dust. It was almost as if Webb recognized the planet by its chemical identity before clearly seeing its body. Finding an unusual signal was not enough. Researchers needed to prove that it came from a planet orbiting Beta Pictoris, and not from a distant background star or another object located in the same direction. Spectroscopy provided another important clue. Light can reveal whether an object is moving toward or away from us through a phenomenon called radial velocity. Using this information, researchers estimated the object's movement, position, and alignment. The results were consistent with a planet traveling around Beta Pictoris and following the same general plane as the system's debris disk. Separate observations using the European Southern Observatory's Very Large Telescope and Webb's NIRCam instrument also supported the discovery. The hidden object was officially identified as a new giant exoplanet, Beta Pictoris d. Beta Pictoris d is believed to be a gas giant. Current estimates place its mass at approximately 2.4 times the mass of Jupiter. Its radius may be around 1.26 times the radius of Jupiter. Although it is enormous compared with Earth, it is believed to be the smallest of the 3 known giant planets orbiting Beta Pictoris. The planet travels around its star at a distance of roughly 26 to 30 astronomical units. 1 astronomical unit is the average distance between Earth and the Sun. This places Beta Pictoris d in a region comparable to Neptune's orbit in our own solar system. 1 complete orbit may take approximately 91 Earth years. Of the 3 known planets in the system, Beta Pictoris d has the widest orbit. However, it still remains just inside the inner edge of the giant debris disk, and that location may help explain why the planet matters so much. Astronomers had already noticed that the Beta Pictoris debris disk contained unusual structures. Its inner edge appeared surprisingly sharp. Normally, dust and debris might be expected to spread more gradually throughout a young planetary system. But planets can shape debris disks through gravity. The planet may have been sculpting the disk for millions of years while remaining hidden inside the very dust it was influencing. As a massive planet travels around its star, its gravitational influence can clear material from certain regions, create gaps, and produce sharply defined boundaries. Even before Beta Pictoris d was detected, some researchers had predicted that another planet might be present in the outer region of the system. Such a planet could explain why the debris disk looked the way it did. The discovery of Beta Pictoris d suggests those predictions may have been correct. The planet may have been sculpting the disk for millions of years while remaining hidden inside the very dust it was influencing. Thousands of exoplanets have been discovered, but most have not been photographed directly. Astronomers frequently find planets by observing their effects on their host stars. A planet may cause its star to wobble slightly, or it may pass in front of the star and temporarily block a tiny amount of light. Directly detecting a planet is much harder, especially when it is buried inside a bright disk of dust. Beta Pictoris d is important because its atmosphere was detected through its chemical signature before the planet was clearly separated through conventional imaging. This technique could help astronomers discover other hidden worlds in dusty or complicated star systems. Some planets may already exist inside telescope data, but remain unnoticed because their light blends into surrounding dust. Instead of asking only, "Can we see a bright point?" scientists can also ask, "Can we detect the chemical fingerprint of an atmosphere?" That change in approach could reveal planets that traditional imaging methods miss. The discovery also makes Beta Pictoris extremely unusual. It is now only the second planetary system known to contain at least 3 planets that have been detected through imaging-related observations. This gives astronomers a rare chance to compare several young giant planets orbiting the same star. Scientists can study their masses, atmospheres, temperatures, orbits, and interactions with the surrounding debris. Because the system is so young, these planets are still relatively hot from their formation. Studying them may provide clues about how gas giants develop during the earliest years of a planetary system. Beta Pictoris could therefore help scientists understand not only distant worlds, but also the early history of our own solar system. Jupiter, Saturn, Uranus, and Neptune formed billions of years ago. We cannot travel back in time to watch that process. But by examining young systems such as Beta Pictoris, astronomers can observe similar planetary development happening elsewhere in the galaxy. Beta Pictoris has been observed by some of humanity's most advanced telescopes. Yet even after decades of research, a giant planet remained hidden inside the system. That raises an intriguing question. How many other planets are concealed inside the dust surrounding distant stars? Some could be smaller gas giants. Others could be rocky worlds that are currently too faint or too close to their stars to detect. The discovery of Beta Pictoris d does not prove that every dusty system contains hidden planets, but it demonstrates that even famous and carefully studied systems can still surprise us. Sometimes the universe does not hide its secrets because they are impossibly far away. Sometimes those secrets are buried inside information we have already collected. We simply need a new method to recognize them. Beta Pictoris d was not found during a dedicated search for an unknown planet. It appeared while scientists were studying another world. Its presence was revealed through a pattern of carbon monoxide hidden inside Webb spectroscopic data. The planet had been orbiting inside one of the brightest debris disks known, shaping its surroundings while remaining almost invisible to conventional observations. This discovery shows that the James Webb Space Telescope is not simply producing sharper pictures of space. It is allowing astronomers to identify distant worlds through their chemistry. And as scientists apply this method to other star systems, Beta Pictoris d may be only the first of many hidden planets waiting to be uncovered. Because in the universe, what we cannot clearly see may still leave a fingerprint. This is Hidden Verse, where the deepest mysteries of space, history, and our world are finally revealed. Subscribe for the next mystery.